Same thing, Coulomb force. I'll be giving you some more type of questions. So first we need to understand how to represent students. So we'll understand how to write in vector form. How to write Coulomb's force in vector form. Suppose I'm having a charge Q1 and another charge Q2. Now we were only considering the magnitude. And yesterday in few questions we included IJ concept where we were using vector form. Whenever there are two charges or any body, we need to have a understanding of the position, where exactly they are in the space, where exactly this charge is. To know its position, first we must be aware about the origin, from where you are looking at. If you want to know how far a place is, you should know from where you are talking. Simply someone is asking me how far is Mumbai. How far is Mumbai? So the question should be from where. In general, we consider wherever the observer or the questioner is standing, that point as origin. And then someone is asking me how far is Mumbai, so I understand he is asking from that point. But if in general, if someone is asking me on call and I don't know where that person is, he's simply asking me on call, where is Mumbai? I won't have any answer. Because I need a reference point. So similarly, when there are few charges on this board, like there are few charges I mentioned, without mentioning the reference point, I'll not understand where exactly they are lying at. So we always need a origin. We always need a origin point. And in vector form, we have understood any point will require two components, x component and y component. Two components. To know its position, you will be requiring two things. And we would be representing this as, let's say, R1. Position of charge Q1, let it be R1 vector. And position of charge 2, let it be R2 vector. What do you mean by R2 vector? Generally, this R2 will represent the x coordinate and y coordinate of Q2. R1 will represent x coordinate and y coordinate for Q1. So they are the position vectors. R1 and R2 here are position vectors. And this is origin. R1 is representing position of Q1, R2 is representing position of Q2. Now, as I have considered both the charges to be positive, if I consider both the charges to be positive, there would be some force on them. Let's say Q1 is applying some force on Q2. Q1 is applying some force on Q2. And even Q2 will be applying some force on Q1. So we'll be trying to understand will the forces be equal and what will be their directions. So when Q1 is applying certain force on Q2, we need to understand the direction. See, magnitude is very simple. The magnitude of force is very, very simple, which we have already discussed yesterday. But today we are writing Coulomb force in vector form. So when we are talking about two charges, Q1 and Q2, this is R1 vector, this is R2 vector. What would be this vector? You might have studied in your 11th standard triangle law. If this vector is R1, this vector is R2, what would be this vector? How can we name it? It's a very basic thing. If you are having two vectors, R1 and R2, yes, any idea? यहाँ पे इसकी पोजीशन है R1 वेक्टर और इसकी पोजीशन है R2 वेक्टर. How will we name this vector from Q1 to Q2? No one is aware about it. This is something which we cover in 11th standard in the beginning of, I think, in the first month you will be understanding it. It's very, very important. Vector form अगर आपको नहीं आता, how are you preparing for your exams then? Competitive exams के लिए. R1 and R2 triangle law apply करना है. You have to apply triangular method. What happens in triangle method? If you are having two vectors in this way, they are connected from the same origin. They have same origin, and you have to add and get this answer. Please understand, in a triangle law, there's a method. If you are having three vectors in this form, if you are having three vectors in this form such that they complete a circle. Suppose this is vector A, this is vector B, and this is vector C. And if they complete the whole circle, you can simply say A vector plus B vector plus C vector is 0. This is triangular method. Three vectors which come wherever from wherever you start, you come back to the same position. Then you can apply this. But here the problem is A vector is going in this direction, this vector is going in this direction. But again, this is ulta. This is ulta. This is not making a proper triangle. It is not making a closed loop because they are not in the opposite direction. They are going towards same direction. So what we can do here is, this is vector A, this is vector B. We can just simply reverse the sign and consider it to be minus B vector. You can do this. You can just reverse the sign and consider it to be minus B vector. And let this be R vector. Let this be R vector, and I want to find value of R in terms of R1 and R2. Okay. So this is R1 vector. Here, because we are reversing, we are reversing the signs. I will be considering minus R2 vector, and this is R1. You can clearly see R1 plus R plus minus R2 vector is equals to 0. R1 vector, R vector plus minus R2 vector, sum of these three vectors will be 0 because they are making a closed loop. They are making a closed loop. I can now open this bracket, R1 vector plus R vector, and this is plus minus R2 vector equals to 0. R1 vector plus R vector minus R2 vector is 0. Now if I send this minus R2 on the opposite side, or let's say I'll be sending both the vectors on the right hand side. So I'll be getting R vector as, this is minus R2, on right side it will be R2. This is positive R1, on that side it will be minus R1. R2 vector minus R1 vector. So R vector is nothing but R2 vector minus R1 vector. R2 vector minus R1 vector. So this is how we write in vector form. Now, what I am doing, please understand, I have just mentioned the direction till now. So I am mentioning that Q1 to Q2, the direction will be R1 vector minus R2 vector minus R1 vector. Direction from Q1 to Q2. We already know the magnitude of Coulomb force. We are already aware about that. Coulomb force, when we write only the magnitude, it is K Q1 Q2 upon distance square. But when you have to write in vector form, you have to mention the direction. It is very, very important. So it will be K Q1 Q2 distance square and R cap. This is how we mention. What is R? This direction. And why do we provide cap? Because if I write R, if I write in vector form R bar, it will be having some magnitude also. इसका कुछ number भी होता है. ये उससे multiply हो जाएगा. Please understand, you have to just mention the direction. Whenever you want to just mention the direction. This is what I am teaching is of 11th standard. Please understand. I am trying to explain in a short way because no one is responding. So either you are very, very clear with the topic or you don't know what is vector exactly. This is not only for 12th standard. This is already covered in 11th. Here we write R cap. What do you mean by cap? See, when you want to just tell someone go in this direction and you don't want to mention how much distance he or she should cover. You're just mentioning the direction. So we use this cap. And this R is, we already solved this into this form, R2 minus R2. K, Q1, Q2 upon what will be the distance? The distance is R2 minus R1, R2 minus R1 magnitude square. Please understand, when they are asking you the distance, you cannot write that in vector form. So what we will be doing, distance between these two charges is R2 minus R1 and you will apply modulus. That means magnitude. That means magnitude of R2 minus R1. I need to give you a few questions to, if you are not clear with the vector form, this is first step you are concentrating, then we have to solve few questions only, then you will understand its application. Into R cap. Now what is R cap? R cap or any cap can always be written as R vector upon magnitude of R. Whenever you are having this thing, this kind of sign R cap, it means R in vector form divided by its magnitude. So here also we can write the same concept. And what is R? R is R2 minus R1. R is R2 minus R1. See, this thing is not given in your textbook properly. This what I am writing is important. R2 minus R1 square into R upon magnitude of R. Again, magnitude of R. This is R vector. So here I will simply write R2 minus R1 in vector form. But here this is magnitude of R. So again here I have to apply magnitude sign. Or else you can also only leave it here. This is important, but for the starting purpose, if you are not very thorough with vectors, just you can leave the answer here. K Q1 Q2 upon D square, and instead of R cap I will write R2 minus R1. R2 minus R1. I need to write in this form only, because either we can simplify it entirely or we may leave it here itself. We cannot just simply write R2 minus R1 directly. First I have to write R cap into this form, only then I can write R2 minus R1. So the main concept I want to explain here is, this is force by 1 on 2, by charge 1 on charge 2, by charge 1 on charge 2. And what would be the force by 2 on 1? What would be the force by 2 on 1? So the force magnitude remains same. Magnitude will be same because the formula is K charge 1 charge 2 upon D square. But the direction will be opposite. Q1 is applying force in this direction, where Q2 will be applying the same force in opposite direction. So here we should mention minus R. It will be opposite in direction. So again here overall net force of the system is not changing. There is no net force in the system. There is no external force of the charges. Whatever force they are applying is equal and opposite to each other. The force what they are applying will be equal and opposite in direction. This was somewhat theoretical. Let me give you a question that would be helping you. Suppose I am having a charge here, 2, 5. And charge is 2 coulomb. And another charge here, 5, 9 of 3 coulomb. I need to find what would be the force on 3 by 2. Find force on 3 coulomb by 2 coulomb in vector form. So when they say vector form, along with the amount of force, you need to mention the direction also. Along with the magnitude of force, up to direction we mentioned. So we clearly know this is positive, this is positive. So obviously this will be, force will be in this direction. 2 coulomb will be trying to push 3 coulomb. Find force on 3 coulomb due to 2. So I am only considering this one direction. Okay. Now, the force magnitude is K Q1 Q2 upon R square. So for that, Q1 value is aware, I am aware of. Q2 I am aware of. What is R? What is distance? Can anyone tell me what would be distance between them? And if no, how to find it? This is taught in class 9. Let's see. Are you thorough with your basics or not? How to find distance between these two charges? This is taught in class 9. Try to answer. If you put efforts, you will be getting some benefits from me. I'll be also putting equal efforts, more efforts. I'll be putting my efforts even if you don't do. But if you are showing interest, I'll be helping you in whatever way I can. Tell me how to find distance between these two charges. Yes, Darshan Jain, tell me. If you don't know, tell me no, but I need an answer. Because I'm recording the lectures, I need an answer. If you don't know how to find, tell me. How to find distance between this charge and this charge. This charge is at 2,5 and this charge is at 5,9. How to find distance between these two charges? Kabir, Dhwani, yes, Darshan, tell me. Yes, Darshan, please answer. Please unmute yourself. Don't know. Okay. Dhwani, tell me how to find. I need an answer. If you don't know, tell me if you don't know. Dhwani, answer. I have to remove you from the lecture. You also don't know. Great. Kabir, how would we find distance between these two charges? Kabir Tomar, respond. Tomar. Kabir Tomar, please respond. If you're not responding, I have to remove you from the lecture. If you don't know, please say you don't know. I'll explain that. Kabir Tomar. Kabir Tomar, please respond. Ramya. Yes. But how to find that distance? That's my question, Ramya. How to find the distance? What is the concept behind it? Sankalp. Don't know. Tarang. Tarang Sharma. Kabir, I'm asking you for the last time. If I'm audible, please respond or else I cannot keep you in my lecture. If you don't know answer, you can tell me. Okay. So everyone else, if you just want to attend, see, I'll be taking your names from now. Just don't attend for namesake because I cannot allow you. If you don't know, not a problem. I'll try to teach. That's my job. Yes, Ramya, your answer is right. Great. It's not that you don't know. You know the method. You know. Everyone is aware about it because you have used it in 9th, 10th, and 11th, all these exams. If you are here in 12th, you are aware about the method, but you are not applying your logic brain here. See, 2,5 is position and 5,9 is position. How to find distance between any 2 points on a graph? Use distance formula. What was your distance formula? Under root x2 minus x1 whole square plus y2 minus y1 whole square. 5 minus 2, 3 whole square. 9 minus 5, 4 whole square. Square of 3 is 9 and square of 4 is 16. It will be under root 25 and root 25 is 5. So this is your distance. Now, there's one mistake earlier you did. I have never mentioned, I have not mentioned anywhere it's centimeter or meter. So if it is not mentioned, you can simply write units because we don't know it will be meter or centimeter if it is not mentioned in that situation. So this is 5 units. The distance is 5 units. Now I'm aware about K, I'm aware about Q1 2 coulomb, Q2 is 3 coulomb, and I'm also aware about the distance. What about direction? How to mention this direction? Is important, please understand. K, 9, value of K, let it be as it is, because that's a simple constant, we can apply that later on. Q1 is 2 coulomb and Q2 is 3 coulomb and distance between them is 5, so 5 square. And how to mention the direction, please understand, it is really important. Whenever you want to mention the direction, what you have to do is first write this as r cap upon r magnitude. R cap upon r magnitude. It is very important. Sorry, r vector upon r magnitude. R cap को पहले आपको ऐसे लिखना पड़ेगा r vector in vector form upon magnitude of r. But what exactly is r? What exactly is r? So how to find r is very simple. X minus x. 5 minus 2 is 3, and it will be I. R2 minus R1. When I write 2 comma 5, what is exactly 2 comma 5? This is R1 vector. 2 comma 5. This is I am writing in coordinate form. This coordinate form, when I have to mention in vector form, it is 2I phi j. 2I phi j. Where I is something which is related to x component and j is y component. So whatever x component you are having, you will write 2I cap and phi j cap. I means x direction, j means y direction. What is position of this charge in vector form? What would be the position of this charge in vector form? So it will be phi I cap 9 j cap. Phi I cap and 9 j cap. What do you mean by this? This is nothing but जैसे आपने position 2,5 और 5,9 लिखी है, उसको coordinate form, Cartesian form बोलते हैं. This is vector form. And in the previous topic मैंने आपको explain किया था how to find r vector. R vector is nothing but r2 vector minus r vector. R vector is nothing but r2 vector minus r vector. ये formula से भी समझाऊंगा, मैं आपको logic से भी समझाऊंगा. R2 is 5 I cap plus 9 j cap minus R1 is 2 I cap plus 5 j cap. Now when you have to subtract them, you will be subtracting I component with I component and j component with j component. 5i minus 2i. So this is 3i. 9j plus 5 minus 5j. So this will be 4j cap. Now this is r vector. Please understand, आपको r vector मिल गया, आपको ये direction मिल गई. This vector is known. 3i cap plus 4j cap. 3i cap plus 4j cap. Because you are not thorough with the topic, I'm taking the topic very slowly. Or else you can simply you could have done this things. क्या करना होता है? Very simple. इसका x और इसका x minus करो. 5 minus 2, 3. Right? This is 3i cap. Then y minus y, j cap. Always remember, if your direction is ulta, if your direction is opposite, you have to always subtract from the point where this arrow is going. वो final point होता है, उसमें से initial minus करना होता है. So if the arrow is going in this way, so this is final point. From this, I will subtract this point. Always. Okay. So 5 minus 2, 3. 9 minus 5, 4. So that this direction is 3i cap plus 4j cap. Any doubts in this? How to find this direction? Okay. Now understand one more thing. 3i cap plus 4j cap. Now you have to understand one more thing. That is vector. You have only found the direction. But still, this is having some value. This is having some value. When you have to only mention the direction, its magnitude should be 1. उसका magnitude होना चाहिए 1. When you have to only mention the direction, इसका magnitude आप लोगों को निकालना आता है first of all. So be honest. Yeah. So r vector is 3i cap plus 4j cap. This is the r vector. But when you have to write r cap, how to find r cap? R cap is r vector divided by its magnitude. How to find magnitude? So magnitude is under root whatever the number you are having with I, square of that, plus whatever number you are having with j, square of that. How to find magnitude of a vector? So we will be squaring the term with I and the term with j. Square of 3, 9, square of 4, 16, 9 plus 16, 25, and root will be 5. So our magnitude of this vector is 5. वी आर हैविंग आर वेक्टर, कैसा मिला मैं आपको पूरा समय एक बार फिर से एक्सप्लेन कर दूंगा, वापस सुनते हैं। सो मुझे यहाँ पे because this vector is important even in your maths 12th standard maths you'll be having such questions. There's a whole chapter and 11th standard में आपने vectors हो गए, motions हो गए, electricity हो गए. This is very very important. So our concept is there are two charges. One charge is somewhere here and another charge is somewhere placed somewhere else. The position of, let's say this is 2,4 and here it is 10,10. 2,4 and 10,10. We need to find कि यहाँ पे suppose charge is 3 coulomb and here the charge is 2 coulomb. So obviously this 3 coulomb will be pushing 2 coulomb and 2 coulomb will be pushing 3 coulomb. हमें कोई भी एक find करना है कि 3 coulomb 2 coulomb पे कितना force apply करेगा. Okay, force find करने का जो magnitude है वो बहुत easy है. Magnitude find करने के लिए इतना time waste नहीं करना है. How to find magnitude? Use coulomb force. What is formula for coulomb force? K Q1 Q2 upon distance का square. K Q1 Q2 upon distance का square. अगर वेक्टर फॉर्म में नहीं लिखना है, डायरेक्शन इंपॉर्टेंट नहीं है, तो पहले ये फाइंड कर लो, ठीक है? हाउ टू डू दैट? K की वैल्यू 9 into 10 raised to 9, वो बाद में अप्लाई कर सकते हैं. 9 into 10 raised to 9, 9 into 10 raised to 9. If the medium is air, and as I already informed you, initially we'll already be considering medium as air or vacuum. Air या vacuum होती तो K की वैल्यू यही होगी. In other substance हमेशा K की वैल्यू से कम होगी. That you have to remember. This is maximum value of K. Q1 is 3 coulomb, Q2 is 2 coulomb, and distance between them. Please tell me how to find distance between any two points on this plane. See, even in this concept, you can have a 3D. ये तो 2D में क्वेश्चन दिया मैंने x और y. How to find distance between them? Distance formula under root x minus x, 10 minus 2, 8, square of it, plus 10 minus 4, 6, square of 6, 8 square, 48, 64. 64 plus 6 square, 36. If you add, you'll be getting 100. And on the root of 100, the answer will be 10. So distance is 10. So here I'll be writing 10 square. 9 into 10 is to 9 into 3 into 2. This is coulomb. No need to mention unit as of now. 3 2s are 6. And 6 9s are. 6 9s are will be 54. 54 into 10 is to 9 upon 10 square, 100. Or you can simply say 10 का square 10 is to 9 है. So this will become 54 into 10 raised to 7. 54 into 10 raised to 7 Newton. But here I have only mentioned the magnitude. सिर्फ आपको magnitude मिल रहा है कि what would be the force, but what will be its direction and how to mention that direction, वो भी clear करना होगा आपको. Okay, so one second. 54 into 10 raised to 7 Newton. This is the magnitude of force. How to find the direction? So force will be in this direction. First you need to understand it will be repulsive or attractive. Only then it will be clear. 3 coulomb, 2 coulomb, both positive. It will be repulsive. 3 coulomb will try to push. 3 coulomb will be trying to push 2 coulomb. Okay. So we'll need to find this direction. How to find direction? First of all, whenever you want to mention this coulomb force into vector form, whenever you want to mention this in vector form, see, understand. Magnitude will remain as it is, K Q1 Q2 upon d square. But along with this, you have to mention r cap, where r is the direction. This is direction part and this is magnitude part. I've already calculated the magnitude, 54 into 10 raised to 7. How to find this r cap? So r cap का meaning क्या होता है? R cap का meaning होता है r vector upon उसका magnitude. जो भी आपके पास वेक्टर है उसको उसी के मैग्नीट्यूड से डिवाइड कर देते हैं तो r वेक्टर r कैप मिलता है. r कैप का मतलब क्या है कि वहां पे see whenever we mention a vector तो उसका मतलब क्या होता है you have to go in this particular direction this many kilometers. ये उसका मतलब होता है कि along with the distance you are also mentioning the direction. But when I say cap तो cap का मतलब हो जाता है इसका मैग्नीट्यूड कुछ नहीं, इसका मैग्नीट्यूड 1 है, you are just giving its direction. Whenever you are talking about cap उसका मैग्नीट्यूड 1 है and direction is important. यहाँ पे आपको direction mention करनी है. अगर आप सिर्फ r cap की जगह r vector लिखते हो तो r vector की कुछ वैल्यू है, उसकी कुछ नंबर की वैल्यू है, फोर्स उससे मल्टीप्लाई हो जाएगा तो फोर्स की वैल्यू गलत हो जाएगी. फोर्स का मैग्नीट्यूड यही रहने वाला है. The magnitude of the force will be this much. Here this thing should only mention the direction. It should not multiply the force with any number. So to take care of that, हम उसको अपने मैग्नीट्यूड से डिवाइड कर देते हैं. किसी भी वेक्टर को उसके मैग्नीट्यूड से डिवाइड कर दोगे तो इसकी ओवरऑल वैल्यू हो जाएगी 1, बट इट विल बी गिविंग सम डायरेक्शन. So this is what I am doing. R cap का मतलब यहाँ पे क्या हो गया? We are mentioning the direction and even the force will not change. इसका overall value 1 होगी. Overall इसकी जो value होगी अगर आप multiply करोगे it will be 1. Okay. R cap कैसे find करते हैं? वो बहुत easy है. इस point पे what will be the vector? 2i 4j. 2i plus 4j. इस point पे vector will be 10i plus 10j. 10i plus 10j. And this direction is important. Whenever you have to find r vector, this direction is very important because final minus initial, always final minus initial. From I by yes, correct. I will subtract, j will subtract. 10 minus 2, 8. 10 minus 4, 6. So I am getting 4i cap plus 6j cap. This is your r vector. 54 into 10 raised to 7 into 8i cap plus 6j cap. अगर मैं इसको डिवाइड नहीं करूंगा, प्लीज अंडरस्टैंड, अगर मैं इसको डिवाइड नहीं करता हूं तो प्रॉब्लम हो जाएगी. 54 तो 8 और 6 से मल्टीप्लाई हो जाएगा. द मैग्नीट्यूड ऑफ फोर्स विल चेंज, वेयर इज द मैग्नीट्यूड शुड नॉट चेंज. इसका काम सिर्फ डायरेक्शन बताना है. सो 8 एंड 6 ये जो r वेक्टर है आपको उसके मैग्नीट्यूड से डिवाइड करना है. हाउ टू फाइंड मैग्नीट्यूड? अंडर रूट 8 का स्क्वायर प्लस 6 का स्क्वायर. मैग्नीट्यूड किसी भी वेक्टर का कैसे ढूंढते हैं? जो भी नंबर i के साथ है you have to square that and जो whatever number you are having with j square that, add them and then you have to square root them. So here you will be getting 10. So I'll divide this by 10. I'll divide this by 10. Now you can this is completed. आप इसको और simplified form में लिख सकते हो. 54 into 8 into 10 raised to 7 upon 10. So it will be 54 into 8. 54 into 8 is 432 into 10 raised to 7 upon 10. So it will be 10 raised to 6 I cap plus 54 into 6. It will be 324. 10 raised to 7 by 10 into 10 raised to 6 J cap. अब इसका मीनिंग समझो. इसका मीनिंग समझो. ये क्या फोर्स आया? I cap और J cap का मतलब क्या है? So this force is having two things. ये इस फोर्स को दो डायरेक्शन में धक्का दे रहा है, right? When this force is pushing, so this charge will go somewhat in x direction and somewhat upwards. जब इसको ऐसे push करेगा, this will go in this way. मतलब it is also going forward in x direction and also in y direction. ऊपर भी जा रहा है, आगे भी जा रहा है. But what is the force जिससे वो आगे push हुआ है and what is the amount of force जिससे इसको upward force मिला है? जो I cap के बाजू में नंबर होता है, that is the force in x direction. and J cap के बाजू में जो नंबर होता है, that is force in upward direction. Okay, but what if I want to find net force? I don't want my answer in vector form. I want my answer as a number if I require. So that would be under root whatever number is here, 432 into 10 raised to 6 square plus 324 into 10 raised to 6 whole square, and you will get the magnitude. 10 raised to 6 आप कॉमन निकाल के उसको अलग से कैलकुलेट कर सकते हो. Won't be a problem. 432 square, 324 square, and then you can simplify this. Okay, numbers will be such that वो easily हो जाएगा. यहाँ पे numbers random मैंने लिए. So whenever you want to find, this is your final force, but this is in vector form. This is your final force, but in vector form, ij, vector form. But if you want to find magnitude, जो भी आगे है, जो भी j के आगे है, this is a common thing. यहाँ पे r vector था, उसका magnitude find करना है. I am squaring I term and j term. Here you are having a force, you need to find magnitude, you can do this. I hope you have some idea now. Okay. Now we will be starting with a new type of question. Suppose you have two charges. This is plus 2 coulomb and this is plus 5 coulomb. Plus 2 coulomb plus 5 coulomb. And they are at a distance of 5 meters. I want to place a charge of 3 coulomb, or let's say 10 coulomb. I want to place a charge of 10 coulomb between them such that this is an equilibrium. I want to place this charge somewhere between the line joinings such that it is in equilibrium. And how to do that? Equilibrium का मतलब क्या होता है? Net force 0, net torque 0. Here we won't be talking about torque. वो आगे डाइपोल वाले क्वेश्चन में हम करेंगे. यहाँ पे net force 0. We can clearly see here it will be having repulsion and here also it will be repulsion. Positive positive दूर, positive positive दूर. So you have to find a position. आपको इस 10 कूलम की ऐसी पोजीशन फाइंड करनी है between these two charges so that overall the net force becomes 0. 2 कूलम और इनके बीच में जो फोर्स है और इनके बीच में जो फोर्स है अगर वो इक्वल हो जाता है and they are already opposite, so it will cancel out each other and the 10 coulomb will be in equilibrium position, it won't move. So we want force due to this charge and force due to this charge to be equal. The magnitude should be equal. Direction is already opposite, magnitude if it is equal they will cancel out each other. How to find this? K q1 q2 upon distance ka square. We don't know the distance. I'll just consider the distance to be x. What about F2? K q1 q2. And what about distance? I don't know the distance, but I know total is 5. This is x, so this will be 5 minus x. This has to be 5 minus x. So it will be 5 minus x ka square. K cancel, 10 cancel. So 2 upon x square equals to 5 upon 5 minus x ka whole square. Need to simplify this. Please rejoin everyone. Meeting is about to end.